Hi guys, I hope you're good, I hope you're well and excited for our lesson today. We are still working with exponents and today we are specifically looking at exponential equations. And under exponential equations, we'll be working with the simplest exponential equations, but specifically the ones that have the power as an unknown value. So definitely grab your pen and paper because on this one, I will need you to have all of those resources. So guys, the first part of our lesson today will look at understanding what exponential equations are. So exponential equations have the unknown variable, but they must have the unknown variable as the exponent. So the exponent becomes an unknown. So if you have 2 to the power of x equals any number that can be there, that is an equation, an exponential equation, because the unknown value is the exponent. And secondly, if we can write a single term with the same base on each side of the equation, we can equate the exponents. So we can easily equate the exponents. So this means that this is one of the methods that we use to solve exponential equations. So it means that if you simply have 3 to the power of x equals 3 to the power of 2, if you have that same basis, you can simply equate the exponents. So as long as your bases are the same, you are allowed to equate the exponents, and you can easily solve for x or b or any variable that you're looking for. So the golden rule is, if the bases are the same, equate the exponents. Simple as that. Now, straight to the example. I hope you have your pen and paper ready for this one. So guys, how do we do the first problem? We need to ensure that we break down every value that we can. So since we're solving for x, so this will be 3 to the power of x times 3 to the power of 1. So I took this from which law? The first law of exponents, that when you multiply your exponent, when you multiply, you add the exponent. So if you have a to the power of 2 times a to the power of 3, you need to say this is a to the power of 2 plus 3, which is the same as a to the power of 5. So what I did is I took this first part and wrote it. I took the second part and wrote it like the first part. So basically I said, if I have a 2 plus 3, I can easily write this as a to the power of 2 times a to the power of 3. So that is what I did here. I had 3 to the power of x plus 1. So I can simply write 3 to the power of x times 3 to the power of 1, which equals to, if you want to break down 9 can be written as 3 to the power of 2, because 3 times 3 gives you a 9. So I can write this as 3 to the power of 2. But we are not done yet, as you can easily simplify one side. So I have 3 to the power of x times 3 to the power of 1. So it means here I have 3 to the power of 1 times 3 to the power of 1. And I divide this by 3 to the power of 1. Since we're solving for x, divide both sides. What you do on your left, you must do it on your right. So it means I have simply now cancelled one part, and I also here can cancel at least one of them. So I'm left with 3 to the power of x equal to 3 to the power of 1. And lastly, we go back to the golden rule that says, if the bases are the same, you can now equate the exponents. So as you can see here, we have 3 and 3. So it means we have x and 1 as the powers. So it means we have something like this. Since the bases are the same, as I have 3 there, I have 3 there, I can easily equate the exponents. So this will be x equals 1. So x equals 1. So that is how you get your answer, guys. And if you want to check if your answer is correct, you can check here. If you substitute x equals 1 there, because the question was 3x plus 1 equals 9. So let's check if the left hand side equals to the right hand side. So if I say 3 on the space of x, now I can substitute in the 1. So this becomes 1 plus 1 equals 9. So let's check. I have 3 to the power of 2 now equals 9. And 3 to the power of 2 means 3 times 3 equals 9. So it means I have 9 equals 9. So now you can conclude that therefore the left hand side equals to the right hand side. That is one of the ways of checking your answers if they are correct or not. But the other part of checking if your answers are correct or not, they don't have marks. But if you want to check, just to be sure so that you don't even lose the marks that you try to work on, make sure you try all the time to check your answers. Okay, so example number 2. I hope you're ready. Get your pen and paper also for this one. Try to do it on your own. Pause this video and let's see what you have. So guys, I believe you're done working with with this problem, and let's see how you did it. So the first part is breaking down 13x to the power 13x plus 2. So let's try to break down that first part. So this will be 13x times 13 to the power of 2 equals 169. If I recall properly, 169 can be written as 13 to the power of 2. Why do I say that? Because 13 times 13 will give you 169. And then the second part is dividing by what you have. So I can divide this by 13 to the power of 2, divide this by 13 to the power of 2. And now I can cancel those out. So I have 13 to the power of x equals 1. So if it is equal to 1 like that, you can easily say, you go back to one special rule, guys, because remember you're solving for x now. So there is a rule that says any number to the power of 0 equals 1. So it's one of the exponential rules. If you can go back to our first lesson on exponents, you'll see a rule there saying any number to the power of 0 is 1. So it means we can write this one now in reverse, saying that if I have 13x, I can say this equals to, instead of using 1, I can say this is 13 to the power of 0. See what I did there? Because I was given a 1 already, so I can say 13 to the power of 0, because 13 to the power of 0 is 1. And then you can move on from that. If the bases are the same, you equate the exponents. So this will become x equals 0. And indeed, x equals 0, because if you sub in from 13x plus 2, trying to get 169, you need to say this is 13, and you substitute in the 0 there, plus 2, and let's see if you get 169. And indeed 0 plus 2 is 2, so you have 13 squared equals 169. So this is 13 times 13, which gives you 169. So our answer is correct. So guys, that is how you do these things, and I hope you are practicing. Okay, so I have one more for you, last one, special one, easy. So let's try to do it. It says solve for x, so it should be saying solve for t instead of x. Solve for t if 3t equals 1. 3 to the power of t give you 1. So you simply have 3 to the power of t equals 1. Let me write that again. However, guys, to the same law that I just introduced to you, or I just reminded you of on the previous example, that any number to the power of 0 is 1. So it means I can write this as 3 to the power of t equals 3 to the power of 0. So the reason why I chose 3 is because on my left hand side I have a 3. So I'm trying to have the same basis so that I can easily equate the exponents. So that is why on this problem now I can easily say also t will be 0, because if the bases are the same, you equate the exponents. So guys, that's how you do it. It's quite easy. Keep on practicing, practice. Check your books, they have all of these problems, and trust me, you won't struggle on your exam. So guys, thank you for joining me on today's lesson, and I will definitely see you on the next one.